So yesterday we were looking at the, we looked at this percent of table values, and it's got, the marginal politics, the marginal sex, and we were looking at the question that 19% of the females are moderate, or excuse me, 19% of the class is moderate females, 23% of the class is moderate males. Does that mean that males are more likely to be moderate than females? And the answer is not necessarily. If you look at the numbers, there were a lot more males than there were females. So what we're going to have to do is look at a conditional distribution. So a conditional distribution is where we look at the table and we look at it under one of the two conditions, either under the condition of politics or under the condition of sex, because those are our two, big categories, right? Which we then subdivide into pieces. So that didn't print either, huh?
No, none of us did.
I was like, why are people writing so much stuff down? I'm not saying anything that's all that great. I'm very sorry. I didn't realize that it didn't print.
That's okay.
You're good.
Everybody's good? I caught the stuff that on calculus that didn't print a bunch of stuff. For some reason, the printer is unhappy about printing PDFs that have embedded pictures and other things like that in it, and equations and all that. I don't know why. So anyway, all right. So what we've done here is we're looking under the condition of sex, so we're looking at the totals over here. So of the females, well, that's 35 out of 77. 45% are liberal. Of the females, so when you say of the females, that's your denominator. 36 out of 77, or 46%, are moderate, and only 6 out of 77, or 8%, are conservative. And you should always check, it's like 77 out of 77. Okay, out of all of them, there are all of them. It's not exactly a revelation there. For the males, it's 43, 38, and 18. So the answer to our question is no, actually females are more likely to be moderate than males are. 46% out of 38, or compared to 38. Notice, under the condition of sex, males and females are approximately equal. It's not exactly, but it's close. Later on in the year, we'll talk about, well, how close does it have to be? Okay, we'll actually have a way of doing this where we can look at it and go, that's not close enough, or that is close enough. We'll have a technique for doing it. But for now, you're just kind of like, all right, it's pretty close. So since these two are pretty close, we say that these variables are independent. In other words, there's no association between being female and liberal or male and liberal, right? That happens at about the same rate. So sex does not determine whether someone is liberal or not. It doesn't give you any information. If I told you someone was female, though, and asked about conservative, right? Well, they're way less likely to be conservative than their male counterparts. Okay, now let's turn it around the other way. If you are a moderate, are you more likely to be male or female? And I'll wait while you get all the numbers down.
Oh.
So in this class that we're studying, if a student is a political moderate, they're more likely to be male than female, 55% to 45%. Interestingly enough, the same is true for conservatives. If they're conservative, they're more likely to be male than they are female. It's also true for liberals. If they're a liberal, they're more likely to be male than female. That feels really weird. You're like, wait a minute, how can that be true for all of them? But it is. Right? So there are several things that are like this that feel very counterintuitive. It's like, if you lace your fingers and then you move them down a notch or something, it feels weird, right? Like and if you move them a couple of notches, it feels like, feels really, really strange. This feels kind of strange. You're like, wait a minute. But we're saying, if you take the liberals, are they more likely to be male or female? Part of this is because there were a lot more males than there were females. Right? And that colors this.
So if you did an even amount of males and females, it would be different?
Yes. Yeah, and that's why sometimes when we're designing an experiment, we'll want an equal number of two different kinds of subjects so that we can make some of those comparisons more easily. Right?
Wait, so is this graph like a different group of people than this one?
Nope, same group of people.
Oh, wait, then how does this one have like 45% female liberals and then this is 41%?
Because this is, if they are female, what percent are liberal? This is, if they're liberal, what percent are female?
Oh.
So this is, of the girls in the class, what percentage are liberal? This is, of the liberals in the class, what percentage are girls?
Yeah.
And you see, that's an important distinction. You have to read really carefully. And again, it's the of the liberals. That tells you that we're dividing by the number of liberals. So out of the group of liberals, what percentage are female? Whereas up here, it was of the females, what percentage are liberal?
Oh, I see. Okay.
And it feels like, at first, it's like, shouldn't that be the same thing? And it's like, no, it's really not. Okay? Because it's two entirely different groups. Now, they overlap, but, it's two completely different groups. Okay? One of the things that we'll sometimes use are called segmented bar graphs. So we could display the information in the first conditional distribution table by dividing up bars rather than circles, with one bar representing females and the others representing males. And that would look like this. Did that tell me that printed?
It did, but it's just hard to tell.
Because it's not in color?
Yeah.
Okay.
Are they pretty close together?
It's all in color. Well, if I look
But
close
you can
enough,
just say
Mr.
the
Davis,
top one-
I can tell.
Top one is conservative. Middle one is
Moderate. Oh, no.
And bottom is liberal.
Yes. I'm going to print these in color next year.
This is a study y'all actually did? Or no, this is a...
No, this is one that
This is not the one that y'all did.
no, we needed more people.
Mm-hmm.
There just aren't enough. Again, when you have a really small sample size, it's hard to make comparisons. So in this way, this is conditional on sex, right? What percent of the females are moderate? What percent are liberal, what percent are moderate, and what percent are conservative. You could have also done one for the other. We could have done it under the condition of politics, right? Of the three different political affiliations, what percentage were male, what percentage were female. Now, be careful about percentages across very different values or groups. As when we notice that no matter which political group we picked, a student in that group is more likely to be male than female. Let me give you, and this is not one that you'll ever see on the AP exam, but it's super interesting. Let me let you go ahead and get the numbers for the table.
Yeah, on the other ones there was like maybe one row that was printed. This one there's nothing.
There's nothing.
It's all blank.
Oh. I suppose you can laugh about it, or you can, get mad.
No, I don't care.
I appreciate your help with that.
It's easier to pay attention when you're writing than this. Or like remember it
Oh, yeah.
rather than
Just listening and looking at it all printed. So, the problem that we're going to look at here is an example of something called Simpson's paradox. If you take the averages across different groups, there appear to be contradictions in the overall averages. So here's how the example works. So, and you can check the numbers, it does add up. So it's the last inning of an important baseball game. Some of you don't care at all about baseball. It's fine. It doesn't matter. Your team is a rundown with the bases loaded and 2 outs. Okay?
time for a walk-off.
Pardon?
I said time for a walk-off.
Time for a walk-off. Or, just a walk. That would work as well.
That would work.
Your pitcher, who's not so good at the plate, is due up next. Yeah, this is back in the days when the pitchers actually hit. So you, as the manager, will be sending in a pinch hitter. There are 2 batters available on the bench. Whom should you send in to bat? Here are the players' summary records for the last 4 months of the season. So, let's look at their overall batting averages. That means that Alvarez got 33 hits and 103 attempts, whereas Blyleven got 45 and 151. So for Alvarez, his batting average it's 33 out of 103. And my calculator's probably in my bag.
I got it. Should we use?
Oh, cool. So 33 out of 103.
Uh, 32.03.
Well, it's 0.32,
Oh, yeah. It's a good time.
0.3203.
Mhm.
I hate this eraser. Well, it doesn't show you what you're erasing until you stop moving it. So 3203. And in baseball, it's not important that you understand this, but when they give a batting average, they would say he's hitting 320.
That's good.
They give the first 3 places after the decimal, and they don't explain why. They just say he's hitting 320, and anyone who follows baseball knows that that's what that means. So he has a 320 batting average. Blyleven, on the other hand, there was an actual baseball player, Bert Blyleven.
Is that? I want to say German, but I don't know.
Is it?
Is it
I don't know.
Like a different.
I was hoping he would be like.
It's American.
That's 45 out of 151.
And then
Point what?
29. That's still okay.
2980?
Alvarez better.
Yeah.
Has a 298 batting average. So based on these numbers, who might you choose?
Alvarez.
And I'm about to show you why that's not the right choice.
Oh man. So we just lost the game.
No, Alvarez.
We're
Dang it.
managers.
You might choose Alvarez in this. He's got the better batting average. So this should be a question. Does it matter whether the pitcher is left-handed or right-handed? Let's find the batting averages for left-handed and right-handed for both. So for Alvarez, I'm going to make a little chart. So versus left-handed pitching. Alvarez is 28 for 81.
That is .3456.
So that's a 346 batting average. And Blyleven is 12 out of 32. He's hitting 375 against left-handed pitchers. So if it's a left-handed pitcher, you should send Blyleven in. He's better against left-handed pitchers. And you're like, it's bound to be the opposite when we look at the other one. Au contraire, mon frere. Alvarez is 5 for 22.
That's .227.
He's only hitting 227 against right-handed pitchers. Blyleven, on the other hand, is 33 for 119.
27.7.
He's hitting 277.
Well, dang it, we lost the game.
So-
Put that on my manager.
Why can't you look at the overall stats here? Well, the problem is this. They're both better against left-handed pitchers, right? But Blyleven has had to face right-handed pitchers a ton. 33 out of 119. Whereas Alvarez has only gone up against right-handed pitchers 22 times. This is why the overall doesn't match the individual. Which, again, this is another one of those things where you're like, okay, I don't think I can take any more weird things in one day, right? It feels strange. But it's because, like you were asking earlier about, what if we had in the class about the same number of females as males? That would change a lot of that individual things, right? It wouldn't be possible if there were exactly the same number of males and exactly the same number of females when we looked at conservatives. They were more likely to be males. Liberals, more likely to be males. Moderates, more likely to be males. That wouldn't be possible if the two numbers were the same. So, but because the two groups were different sizes, it is possible. All right? So, probably better to hit Blyleven. And again, this happened because we're comparing different size numbers and we're doing it with a percentage. Okay? Any questions about that?
It's kind of cool though.
It's, again, I always find these things interesting. I'm like, I would have never thought of that on my own. So, all right. That's it for today's lesson.